And then we have equations of condition or construction. There are certain construction details which require special consideration from the design engineer. For example, the beam shown in figure 2.4a has a hinge built in at point B. Yan. So remember na kapag hinge, zero ang moment. Kapag roller, zero din ang moment. Let's take the case of P3, yung load na 3, P3. Magkakaroon siya ng deflection dito. So, ganyan. Pero yung deflection niya, hindi na yan matratransmit dito sa kabila. Hindi na ganyan. So, ang tawag dyan ay condition. Not like yung ating example kanina. Okay? Kapag may support dito, may support dyan, support dito, naglagay ka ng load, ang deflection sana niya, pag ganyan. Okay? So, remember those things. So, ang ibig sabihin, yung hinge dyan ay isang condition. Thus, no moment can be transmitted through the beam at point B. In computations, the condition summation moment B can be imposed on the two segments taken as free bodies in figure 2.4b. Ayan. So, free bodies means yung beam na yan, in-split natin siya ng dalawang free body. So, there are two components of internal force at point B. One parallel to the axis of the member and another perpendicular to the axis. Yung parallel to the axis, that is RBH and RBH. Okay, take note na parehas sila. Reaction B, horizontal. Okay, H means horizontal. Remember na they are both the same, pero opposite in direction. So that is simply conditions of equilibrium again. And another one, perpendicular to the axis. Perpendicular, ito yun. Reaction at point B, vertical. Again, you have two reactions. Isang downward at isang vertical. Pareha sila ng value but opposite in direction. Now let's go here. 2.5 indicates three construction details or conditions that give rise to equations of conditions. So remember, this is hinge and then we have roller. Then we have link. The hinge in figure 2.5a yields one equation of condition. Summation moment B is equal to 0. Ito, okay? The roller in figure 2.5b gives two equations of conditions. Summation moment B is equal to 0 and summation forces vertical equal to 0. The force parallel to the axis of the members is 0. The link in figure 2.5c can only transmit force along its axis with two equations of conditions. Now let's go to this point. Obviously, summation forces vertical dito sa point B is also 0. Pero, roller yan. So, yung equation ng summation forces horizontal do not apply. For example, along AB, naglagay ka ng horizontal force. Sa palagay niya yung horizontal force na yan, matratransmit dito. Hindi siya matratransmit. So, yung summation forces horizontal does not apply to your roller support. And finally, the link figure 2.5c can only transmit force along its axis with two equations of conditions. Summation moment B equal to 0. Summation moment C is equal to 0. How about dito sa link B and C? Summation forces vertical and summation forces horizontal do not apply. Okay? If it is vertical, it would act like roller and only vertical reactions. Components would be transmitted to the two beams. Calculations of reactions for structures with links and hinges are illustrated in 2.5 to 2.7. Now let's go to free body diagrams. In solving problems concerning the equilibrium of rigid bodies, one of the most important concepts is that of the free body diagram. Okay, let's take an example of a free body diagram. Ang FBD is composed of the X and Y axis and then forces Remember that it should be coplanar, and sometimes it should also be concurrent. Yan. Okay, let's take the x and y axis. So this is the x, then we have the y, and then we have the forces. Let's say, meron tayong force 1. Tapos, meron ding force 2. Let's say, force 1 is equal to 10 kilonewton. Force 2 is equal to 5 kilonewton. Okay, so F1, those are the two forces. Are they coplanar? Yes. They both lie in the x and y plane. Are they concurrent? Yes, they are both passing at this point. Okay? For sign conventions, a positive sign is used for tension, since a member subjected to tension increases its length, becoming longer. For a member in compression, adopt a negative sign. Then clockwise, positive. Counterclockwise, negative. In certain cases, it is not possible to determine the direction of a force or reaction. Assume a direction, and if upon completing the solution, the numerical value for the reaction is positive. For deflection of horizontal beams, a downward deflection is considered negative. An upward deflection is positive. So let's draw that. So we have here the free body. So x and y. A positive sign is used for tension. Let's say, meron tayong tali, rope. And then, nag-apply ka ng force. Ano mangyayari sa tali? It will elongate. Okay? So, humaba siya. This is your original length. And then you have delta L. So, for tension, your sign convention is positive. Next, we have compression. Let's take the case of a column. Okay, column. Let's take this column for example. Ang mangyayari sa poste, kapag naglagay ka ng axial load, what do you think will happen to your column? Siyempre, magkakaroon siya ng displacement pababa. Mag-shrink siya. Ang tawag dyan ay compression. Ang sign niyan ay negative. Since nag-decrease yung kanyang length, ang sign natin dyan ay negative. Okay, so next, for clockwise moment naman. So, clockwise, gagamitin natin ay positive. Sipin mo na lang yung relo. Okay? Time moves forward. So, it is positive. Kapag counterclockwise, gagamit tayo ng negative sign. Okay, next is deflection naman tayo. Let's take the case of a beam. Kapag naglagay ka ng load, magde-deflect siya pababa. A downward deflection is considered negative. Okay, so downward deflection is negative. Why negative? Dahil yung direction niya ay pababa. Remember na ang x and y axis, this direction going to the right is positive, then direction going to the left is negative, direction going down is negative, direction going up is positive. Okay? So, anong direction nitong deflection? It is downward, so gagamit tayo ng negative. Now we go to principle of superposition. In many problems encountered in the study of structural analysis, the structure is subjected to several forces and to various types of forces, uniform, concentrated, triangular, etc. The analysis may be performed using the principle of superposition. When a linear relationship is assumed to exist between the applied loads and the resulting displacements in a structure, the forces acting may be considered separately and the structure analyzed for the separate cases. The final result will be the algebraic sum of the individual results. This principle applies in general to reactions, shears, moments, stresses, deformations, and displacements. Ang ibig sabihin ng principle of superposition is something like this. Let's say meron tayong beam. Meron tayong in-apply na uniform load. Okay, let's take this as W. Let's say this is 5 kilonewton per meter. Note that this is a uniform load, so meron tayong reaction. Let's take this as, let's say, 4 meters. Note na itong uniform load, you can simplify this as something like this. Isi-simplify mo siya as a concentrated load applied at a single point. Okay? So, dito siya. Ito yung kanyang length. So, ang application ng uniform load, you can simplify that to be applied at the midpoint of the length. So, this is at 2 meters and 2 meters. Now, what is the equivalent load of this? So, this simply becomes now 5 kilonewton meter. Multiply that by the length 4. So, this now simply becomes 20 kilonewton. So, magiging concentrated from uniform load to concentrated load. So, ang tawag dyan ay principle of superposition. Meaning, you simplify the load to a single point load. So, this is for uniform loads. How about, take note, for a uniform load, ang kanyang centroid is nasa gitna. It is at L over 2. So, this is rectangular load. Punta naman tayo sa triangular loading. Something like this. So, ito yung beam. Okay, meron siyang triangular load. From 0 to, let's say, 3 kilonewton per meter. So, yan ang kanyang triangular load. By principle of superposition, pwede mo yung i-convert na point load or concentrated load. So, from triangular load, by principle of superposition, this now becomes concentrated load. So, we are applying it in one position, which is here. Ngayon, ano na ang kanyang dimension? Let's say, the length here is 6 meters. Ang centroid ng triangle is at 1/3 of your length. So, this now becomes 2. And this becomes now 4 meters. And what becomes of this concentrated load? So, this becomes now simply the area, 3 kilonewton per meter. Multiply that by L, which is 6 meter, divided by 2. So, 18 divided by 2 becomes now 9 kilonewton. Yan. Yan ang equivalent niya by principle of superposition. So, how about stability and determinacy of structures? Structural stability and determinacy must be judged by examining the reactive forces together with the effects of connections such as hinges, rollers, and or links. Consider the loaded beams shown in figure 2.6. Yan. So, sa letter A, ito, statically determinate. B is statically indeterminate. and then C, statically unstable. Note na nandito sa left, yan yung mga figures. Tapos yung drawing dito sa right, yan naman yung mga free body diagrams niya. Dito sa figure A, this is statically determinate in the sense na yung buong body, hindi siya gagalaw sa horizontal, hindi siya gagalaw as a whole, vertical. Ganon din sa figure B, hindi siya gagalaw as a whole. Pero sa letter C, this figure, gagalaw siya as a whole on the horizontal. This becomes now statically unstable or mechanism. Meaning, mag-apply ka lang ng slight load horizontally, gagalaw na siya. So it becomes unstable. The beam in figure A is statically determinate with 3 independent reactive forces which can be calculated by 3 available equations of static equilibrium. Summation forces horizontal, summation moment A, summation moment B is equal to 0. As a check, we can apply the additional equation summation forces B equal to 0. In figure B, it has one additional reactive force which can only be determined using an equation of deformation. It is statically indeterminate with one redundant reaction. For the beam in figure C, there is no force to balance the horizontal component of P and is free to translate. Yan. Translate means it is free to move. It is statically unstable and is termed a simple mechanism. The foregoing procedure may also be applied to cases where construction details or connections are present, as illustrated in figure 2.7 with a roller at B. Yan. So this is at point B. Again, this is your figure. Then this is the free body diagram. Let's look at figure A. May roller doon, pero naka-fixed si A. So meaning, hindi gagalaw yung buong structure. So this is determinate. But it is stable. Okay? So stable simply means na hindi gagalaw. Dito naman sa figure B, stable pa rin yan. But it is statically indeterminate. Pero if you look at figure C, naka-hinge dito, naka-hinge doon, may roller. This now becomes unstable. Gagalaw yung buong structure. Thus, the behavior of beams can be classified according to their reactions by considering the relation between the number of reaction components and the number of equations available. If R is the number of independent unknown reactive forces and C is the number of equations of conditions, we have the following criterion. Okay. Tingnan muna natin yung R. R is simply reaction. There are 3 kinds of reaction. So number 1, you have vertical reaction or R sub Y or R sub B. Then we have horizontal reaction which is R sub X or R sub H. And finally, we have moment reaction. Okay, so ito yung rotation. So tatlo yan. Next, we have C. C is simply your condition. C is 0 for a beam without internal construction details. C is 1 for hinge and then 2 for a roller. So remember, kapag may hinge sa gitna, 1. Kapag may roller, 2. For example, ito. Ano ang value ng C dito? Since this is roller, ang value ng C mo ay 2. Okay? How about here? What is the value of C dito? It is a hinge, kaya ang value ng C mo dyan ay 1. Let's look here. For figure A, the value of C here is 1 since we have a hinge. Okay? Remember, C is 1 for a hinge. Dito, sa figure B, your C value here is 2 kasi roller siya. How about the C value for link? Okay? So, C value for link, wala siyang sinabi. Now, let's look here. If R is equal to C plus 3, the beam is statically determinate. If R is greater than C plus 3, statically indeterminate. If R is less than C plus 3, the beam is statically unstable or it is a mechanism.